Yes, good evening everyone. Please turn on your video. Okay, so today we are going to start a new chapter, that is surface area and volume. Okay, so first of all, tell me what exactly is area you should be knowing. If I say that is this area of a rectangle, if I say area of this rectangle is 10 square centimeter. That means if this is 2 and this is suppose this is 4 and this is 5. So before starting with surface area and volume, first tell me, if this is 4 and this is 5, what will be the area of this rectangle? That is 20 square centimeter. Yeah, length into breadth. But what exactly 20 is in this rectangle?
The space inside the rectangle.
Means what exactly the space? The
Sir,
space
if
is
we
The
what?
make a
interior
grid,
part of the
then
How
rectangle.
we can measure that 20?
sir, if we make a grid and then it will fit exactly 20 squares in that rectangle.
Yes, exactly. That will be if we make a grid. That means if we make a grids like this, means if this is a 4 centimeter and if we draw 4, means if each of this is of 1 centimeter, and if I make this also as if I make 5 grids over here also, 5 lines, means 5 boxes in total. Okay, and if you count it total, that is 1 2 3 4 5 6 7 8, and you will get 20 boxes in it. That's why the area is said as 20. Okay, sometimes students does not know this also, that's why I explain it this in the beginning. How many of you was not knowing this in the beginning, means before the class? Is there anyone? Sometimes there are students like that also. Yeah, fine, no problem. Next, now let us understand what is surface area and how to find surface area of a cuboid. First, what is cuboid? What is the difference between cube and a cuboid? Anyone?
2D and cuboid is 3D.
And cube is what? 3D, 2D.
Sir,
Yeah,
sir, a cube is a 3D square, but while a cuboid is a 3D rectangle.
yeah, you can tell that. That is fine. A cuboid has all the sides are equal, and sorry, a cube has all sides are equal, and in the cuboid, the opposite sides are equal. Yeah, means if this is a square, if this is a square, and if I make this, this will be what? This is a cube. Why? Because all sides are equal in it, right? But if I make it like this, and if I join this, yeah, this will be a cuboid. Yeah, because over here, this means all the sides are not equal. The length and the breadth and the height will be different. In this, if I say this is length, if this is height and this is breadth, all of them are equal. You can what you can say, this is length and this is also length. Over here, if this is length, this is breadth, this will be height. Which one? This length. This will be height. Okay, height of a cuboid. First, we'll understand what is surface area of a cube and a cuboid. If this is a cube, and if you want to find surface area of this cube, surface area of cube, that means total surface area means the surface area of all the faces. That means this face, this face, this face, and the backside 3 faces also. Okay, and what do we know? The area of each face is how much? If I want to find what is the area of this face, it will be what? This length into length. And how many faces you have?
Side square.
How many
Sir,
faces?
6.
Six faces, right? If you are playing a Ludo, how many faces it has? It has 6 faces,
Sir,
right?
6.
6 faces, right? So the area of each face is L square. So your surface area will be of a
N
cuboid.
square
6L
into
square.
6.
Exactly. Surface area of cube will be 6 into L square. That gives you 6L square. Fine. That will be the area. Similarly, if it is a cuboid, if it is a cuboid, yeah, if I want to find the total surface area, if I want to find total surface area, so how much I'll get? See, this area, if I say this area will be length into breadth. Yes or no? That area will be length into breadth. But the same area will be there in the top also. Yeah. So that also has to be added plus length into breadth. You can say 2 into length into breadth. Yeah. Plus, if I say this area will be B into H. But this area will be there over here also on this face also. So that is twice of BH. Yes or no? Plus, if I say the top area, this is done. If I say this area, that will be this H into L. That will be H into L, and the same the backside area, that is also H into L, so it will be
Sir,
2HL.
2HL.
So what do you get? 2 into LB plus BH plus HL. That is what the total surface area of a cuboid. Did you understood
Yes, sir.
the total surface area of a cube as well as the cuboid? Yeah, the formula is clear. The next,
Yes, sir.
the next is yeah. So based on this, you have the first exercise. So let us solve it. Now, what is the first question? A plastic box of 1.5 meter long, 1.25 meter wide, and 65 centimeter deep is to be made. It is opened at the top. Ignoring the thickness of the plastic sheet, determine the area of the sheet required for making the box. Okay, let's solve this question separately. Yeah. Now, what they are saying, you have to make a plastic box which is 1.5 meter long. That means if I have to make a plastic box, it is the box is like this. It's like a cuboid only, the previous cuboid. You can take this as a cuboid. This box only you have to make. Yeah. Now what they said, the length of the box, the plastic box is 1.5 meter long. Okay, fine. Now what you have in this question, they have given the plastic box which is 1.5 meter long, 1.25 meter width, okay, and 65 centimeter deep. They have given the deep in terms of centimeter, right? They have given the length in terms of meter. They have given the breadth in terms of 1.25 meter only, and they have given height, that is 65 centimeter. If I want to convert in terms of meter, what I have to multiply? 65 divided by 100 will give you in terms of meter.
0.65.
Yeah, it will be 0.65
Sir, I
meter.
think converting everything to centimeter will help.
Anything is fine. Anything is fine. You can convert everything in centimeter or everything in centimeter. Both are fine. Okay. So the height will be 0.65 meter. Okay. Now the area of the sheet required for making the box. Now they have said that it is opened at the top. That means this at this area the sheet is not required, right? So this area is how much? This area is length into breadth,
LB.
yeah, L into B. So the area required, the area of sheet required will be area of sheet required. What you can do, you can find the total surface area of the box and minus the top area. Yes or no? That is total surface area minus top area.
Sir.
Yeah.
Sir, we can also do that. Instead of taking 2 lb, we can take only one time
That is
lb.
also fine. Anything is fine. Minus LB you can write. Okay, the top area will be LB. Yeah, L into B. Yeah. So you can write it as 2LB plus 2BH plus 2HL minus LB. So it will be 2LB minus LB will be LB plus 2BH plus 2HL. Fine. So L, what is L? 1.5. What is B? 1.25. And then twice of B into H. B is 1.25 and then H is 0.65 plus 2 into HL. H is 0.65 into length. Length is 1.5. Yeah, if you solve this, you'll get the answer. What is the total surface area required, right? So 1.5 into 1.25, I hope you guys know how to do the normal multiplications and all, right? I'm using a calculator over here. 1.5 into 1.25, that gives you 1.875 plus 1.25 into 0.65 into 2. That gives you 1.25 plus this 2 into 0.65 into 1.5. 2 into 0.65 into 1.5. That gives you 1.95. Okay. And now if you add all of them, what you get plus 1.25 plus 1.875 gives you 5.075 square meters. Okay, or you can also say 5.075 meter square. Both are fine. You can write any one of them. Okay, this is what the total area of sheet required. So what you can say, area of sheet required will be equal to 5.075 meter square. Okay, now next, what they have given, the cost of sheet for it, if the sheet measuring 1 meter square is 20 rupees. That means the cost of sheet is 20 rupees per meter square. So what will be the total cost? Now cost of sheet will be cost of sheet required will be equal to area of sheet required, area of sheet required into its cost, or you can say rate, right? So what you can do, 5.075 into 20, that gives you 5 fives are 20, 2 fives are 10, there is already one zero, 2 fives are 10, 2 sevens are 14, 15, 1 carry and then 5, 2 fives are 10 again. How many points? 3. So it will be how much? 101.5 rupees. This will be the cost required. Understood?
Sir,
Yeah.
I'm getting 5.45 meters square.
You're getting
The
5.
first question.
Oh, wait. Is there anything wrong in this? Wait, let me check it again.
Sir,
Yeah.
sir, 2 into 1.25 into
Wait.
0.65, how it came 1.25?
Yeah, it will be 1.625. This will be 1.625. That's why the whole answer will change. This is 1.625, and if you add all of them, what do you get is wait, plus 1.875 plus 1.95. So that gives you 3 point. Wait, this is 1.95. No, that's right.
Sir,
6.5
1.95 is
plus
correct.
1.95. Wait. Just a moment. 1.875 plus 1.625 plus 1.95 gives you 5.45. Yeah, the addition of this we made it as wrong. This will be 5.45. Okay, and this will also be 5.45 meter square. Okay, this will also be 5.45 over here. Okay, and over here also it should be 5.45. Yeah, over here also it should be 5.45, and then 2 5s are 10, already 1 0, 2 4s are 8 9, 2 5s are 10, and 3 decimals, sorry, 2 decimals, so it will come over here. So answer is 109 rupees. Got it? Yeah.
Yes.
Okay, so that's it. So this is what the cost required for the sheet. Now let's solve the next question. This first question is clear. The next, the length, breadth, and height of a room are 5, 4, and 3 meter. Find the cost of whitewashing of the wall of the room and the ceiling at the rate of this. See, when you are doing the wall wash and whatever, right? We won't be doing the wall wash or painting on the floors, right? There will be a tiles on the floor, right? So you have to avoid the floor. You have to take the total surface area of the
Sir,
box.
ceiling?
Ceiling also will be doing, no, that's what they are saying.
Okay.
Why whitewashing the walls of room and the ceiling? On the ceiling also the whitewash is done.
Okay, sir.
Yeah,
Yeah,
when
yeah.
we are doing painting, at that time we also paint the ceiling, right? Yeah. Now they have said 7.5 rupees per meter square. It is the same kind of question. Now at this time you have to subtract the base area. Got it? You will try this at home.
Yes.
Okay. The next, the floor of a rectangular hall has a perimeter. Wait. The floor of a rectangular hall has a perimeter. If the cost of painting the four wall at the rate of is 15, find the height of the wall. Okay, let's do this. What they said, the floor of a rectangular hall. Let's take the cuboid only again. Suppose this is your hall. Okay, and this will be your floor, right? Wait. This will be your floor. There will be tiles over here. Okay. Now what did they say? The floor of a rectangular hall has a perimeter of 240, 250. That means what will be the perimeter of a floor? That is perimeter of this rectangle. That is length plus breadth equals to how
12.
much? 250. Yeah, that is 2 length plus 2 breadth. 2 into L plus B is equals to 250. And what we can say, that is length plus breadth equals 125. Yes or no? Yeah.
Yes.
Next,
Yes,
they
sir.
have said if the cost of painting the four wall at the rate of 10 rupees per meter square is 15,000. They have said they have given the rate as well as the cost. So find the height of the wall. First of all, if the cost of painting the four walls only, so what will be the area of the four walls?
Sir, 1,500.
I don't want the directly the numeric answer. Area of four walls. Area of four walls will be, one is this B and H, that is B into H. But there will be two walls of B into H, so it will be 2BH. This area is also a wall area, that is length into height. There are two areas like that of walls, so you can say 2 into length into height. Got it? Yeah. So this will be the area of the wall, that is 2 into BH plus HL. This will be the area of the four walls. Now what did they say? If the cost of painting the four wall at the rate of 10 rupees is 15,000, that is cost of painting the wall, painting the wall should be equal to what? Area of wall into its rate. Yes or no? Yeah.
Yes.
But the cost is already given,
Yes.
that is 15,000. Should be equal to area of wall. Area of wall we have found, that is 2 into BH plus HL. Yeah, and the rate also they have given. What is that? 10
10.
rupees. Yeah. If I take this 2 and 10 on the denominator, so it will be 15,000 divided by 2 into 10 will be equal to BH plus HL. Yeah, this 0 gets cancelled. This and this will get cancelled. It will be 750 equals BH plus HL. Yeah. Now we got this. That is 750 equals BH plus HL. And find the height of the wall. We have to find what is the height of the wall. Can I write 750 equals, if I take H as in common, it will be B plus L? Yes or no? But B plus L is how much? 125? Yes or no? I can use
Yes.
this B plus L plus B in it. So 750 will be equal to H into how much it is? 1. You can write this as 1, and over here you can write it as 125, and over here you can write it as from 1, right? So the value of H will be 750 divided by 125, right? So you can cancel in the table of 5. 5 25s are, 5 ones are, and then 5 5s are, 150s are, 25 ones are, and 25 fours are 100, 6 are 150. So the value of H is 6 meters. Okay, you can write the final answer. Therefore, the height of the wall is 6 meter. Is that clear? Now the next. The painting on a certain container is insufficient to paint an area equal to this. How many bricks of dimension this can be painted out of this container? What they said? The paint in a certain container is insufficient to paint an is sorry is sufficient to paint an area equal to this. Fine, see to it. Okay. Now what you have? The paint in a certain container is sufficient to paint an area equal to 9.375 meters square. Okay. So means the paint which you have in a container. Okay. Suppose this is your container. Okay. This is your container. And in this you have a paint which can paint off the area the this paint which you have in this, it can cover area of paint which it can cover will be 9.375 meter square, right? This is what you have. Now how many bricks of dimension this can be painted out of this container? Now if you want to paint the bricks, right, if you want to paint bricks, that is suppose if this is your brick, let's say, let's take this only again. This is what your brick is. Okay, the length, breadth and height they have given for the brick also. Okay, the length, breadth and height of the brick they have given is, this is 22.5, breadth is 10, and the height is 7.5. You can find what is the total surface area of a brick. Yeah, and if you divide that
Yes,
area,
sir.
and if you divide this area with the area of the brick, you will get how many bricks you can paint. Yes or no?
Yes.
Can you solve
Yes,
it?
sir.
Yes.
Yes, sir.
Please do it on your own and tell me what will be the number of bricks which you can paint. Please do it on your first. You have to find what is the total surface area of the brick, and then you have to divide the area of the paint which you have, divide with the area of the total surface area of each brick, and then you'll get the total number of bricks which you can paint. Okay, please try doing it. I'll be back in a minute.
Sir,
Yeah.
sir, but area of paint and brick means area of paint is in meter square and brick is in centimeter.
So what? You have to do
So
the
it is
conversion.
okay.
You have to do the conversion.
Okay.
I will give you the conversion also. If you try it, 1 meter equals 100 centimeter, right? And since the area will come in meter square or centimeter square, so 1 meter square, that means you square on both the sides. So 1 meter square, square of 100 will be 10,000
10,000.
centimeter square. Got it? You have to use this conversion to do.
Yes.
Yeah, please do it on your own. I'll be back in a minute. Yes, solved.
Yes, sir.
So
Yes.
Yes, sir.
how many bricks we can paint?
Sir,
100.
100.
Sir, 100 bricks.
So everyone has got it? Yeah?
Yes, sir.
Yes, sir.
Okay, okay, fine. Now let's solve the next one. The next is what they have given. A cubical box has each edge as 10 centimeter and another cuboidal box as this. Which box has a greater lateral surface area and how much and by how much? Which box has a smaller total surface area and by how much? Okay, let's solve this.
Sir, what is lateral surface area?
We'll tell you. Wait. Yeah. The lateral area means this area. The lateral area of a cuboid means this area plus this area plus this area and plus this area. Means the walls area. If it's a
Okay,
roof,
sir.
the area of a walls are what? Lateral area. Okay. So what they are saying, there is a cubical box and a cuboidal box. Okay, let's take the cubical box also. Now what they are saying, a cubical box has each edge as 10. That is, this is 10. Each edge as 10 and another cuboidal box which is 12.5 centimeter in long, okay, 10 centimeter wide and 8 centimeter height. Which box has the greater lateral surface area? So lateral surface area of cube and what will be the lateral surface area of cuboid? Let's find it. What will be the lateral surface area of cube?
4L square.
4 is.
Lateral surface area of cube. Each surface area will be L square and there are 4 faces, so it will be 4L square. So that is 4 into 10 square, that is 400 centimeter square. That is what lateral surface area of a cube. Now let us find what will be the lateral surface area of a cuboid. Surface area of cuboid. Okay, what will be the lateral surface area? See, this lateral surface will be what? B into H, and there will be 2 like
BH.
that. 2BH plus, this is also a lateral surface area. Yeah, that is L into H. So
LB.
there are 2 in this case. So you can write it as 2H into B plus L. Yeah, we know what is,
Sir.
yeah,
So it is L into B.
L into B will be the base area.
Okay. Okay.
Yeah, L into H because this is H, no? L into H it will be. Yeah, so it will be 2 into the height is how much? 8 and B plus L. The value of B is 10, L is 12.5. So that is 2 into 8 into 22.5. 2 into 8 is 16 into 22.5. So 16 into 22.5 is 360. Okay, the answer is 360 centimeter square. Okay, this the lateral surface area of cuboid is 360 and this is 400. So which one is greater? They are asking. Which box has the lateral surface area and by how much? So what we can say?
Sir, square.
Cube, not square. Cube has a
Oh, yes.
greater greater lateral surface area, lateral surface area than cuboid by 40 centimeter square. Got it? Because this is 400 and this is 360. So it is greater by 40 centimeter square. Clear? Yeah. Next, which box has a smaller or total surface area and by how much? The same thing you have to do. Find the total surface area and compare both of them. Understood? Clear? Fine.
Yes.
Now let's do the next
Yes.
question. You please completely solve this question at your home. The second one, the second part also. Now the next. What they have given, a small indoor greenhouse herbarium is made entirely of glass pans, including base, held together with tape. It is 20 centimeter long, this and this. What is the area of the glass? The glass required is the total surface area of the glass. How much of tape is needed for all the 12 edges? How much tape will be required? So what you will have to do? For what? How much tape will
Sir,
be? Yeah.
sir, in that greenhouse, we have to consider top also, means it will be closed.
A small indoor greenhouse is made entirely of glass plants, including base. Yeah, you have to take the top also.
So total surface area.
Yeah, it will be total surface area only. Yeah, and held together with tape. Now, now held together with tape means what? They have been joined using tapes. That means like this. If this is a cuboid, okay. Now this is what your greenhouse, and it is all made up of glass. And if you want to join these glasses by using a tape, the tapes will be required over here, no, like this. You have to join these glasses using a tape. You will be joining them using a tape, right? You will be putting a tape like this over here, and it will be done on all the edges, right? So what they are asking, how much of tape is needed for all the edges of all the 12 edges? See, the tape required, the length of tape required. We'll find only the length of tape required because the area of the glass, that's again the total surface area, which you already know. That is 2 into LB plus BH plus HL. You can do it, right? Yeah. So let's do the tape required. So length of tape required, length of tape required will be equal to. See how many lengths you will have. 1, 2, 3, and 4. There will be 4 lengths. 4 lengths. This breadth will be 1, 2, 3, and 4. There will be 4 breadths, and there will be 4 height also. So what you can write? 4 into L plus B plus H. Okay, that is 4 into L. The length of the wall is 30, 25, and 25. 30 plus 25 plus 25. So that is 4 into 30 plus 50. 50 plus 30 is 80. 80. 4 eights are 32. So 320 centimeter. So this
Sir,
length of, yeah,
so can we do that after finding the area? We can divide it by 12.
no, that will not be same, no. The area is different and this length is different. The area
Okay.
will be the total area, no. This is only the tape length which you have to do. You cannot divide it by 12.
Okay.
Yeah, getting it?
Yes.
The next is Shanti Sweet Stall was placing an order for making cardboard boxes for packing their sweets. Two sizes of box were required, the bigger of dimension this and the smaller of dimension this. For all the overlaps, 5% of the total surface area is required extra. If the cost of cardboard is rupees 4 for 100 centimeter square, find the cost of cardboard required for supplying 250 boxes of each kind. Okay, see over here. I'll solve this. See what they are saying. Shanti Sweet Stall was placing an order for making cardboard boxes. Okay, they are making two type of boxes. Okay, so if I take one of the box as this, okay, they are making two different types of box as you can see. Okay, so the lengths which they have given, the one is 25. This is 25 centimeter by 20 centimeter by height is 5 centimeter. Okay, and there is another box which is 15 centimeter, 12 centimeter, and 5 centimeter. For all the overlaps, 5% of total surface area is required extra. If the cost of the cardboard, see, I am drawing this diagram. This diagram is not required. Huh? I'm drawing it only for the understanding purpose. You don't have to draw this all, right? It will take a lot of time to draw. Yeah, do not draw this diagrams and all. You can directly use length into breadth formula and all. You can directly use it and solve it. Now, what they are saying, for overlaps 5% of the total surface area is required extra. Means whatever the area you have, you will you will need 5% extra area for the overlaps. So you have to find what will be the total cost required if you have to supply 250 boxes of each kind. Fine. Let us find, let's say this is your box 1 and this is your box 2. Okay, we'll find the total surface area of box 1. Total surface area of box 1 will be equal to 2 into LB plus BH plus HL. That is 2 into 25 into B is 20 plus 20 into H, that is 5, plus 5 into L, that is 25. Okay, so that is 2 into 50 plus 2 5s are 10, 100 plus 5 125.
500, no, in the first.
Yeah, sorry,
Yes, sir.
500. Yeah,
500.
yeah, 500. 2 into this 600, 700, 725,
725.
1450 it will be. 1450 centimeter square. That is what the area of first cuboid. Yeah. Now the area required. Now this is the area of each box, total surface area of one box. As they said, there will be a 5% extra required for overlapping, right? When you see a box, there will be some overlapping also. No, there are covers like this over here, right? There are extra areas also, so we'll have to count that also. So that is 5% extra area for overlapping. 5% area for overlapping will be equal to 5% of 1450. So 5 of 100 into 1450, 0 0 cancel, 5 twos are, so 145 divided by 2, 2 sevens are 14, 2 twos are 4, and 72.5 centimeter square will be the extra area required for each box. Yes or no? Did you get it?
Yes, sir.
Yeah. So total
Yes.
area required
Sir,
for box
so,
1. Yeah.
sir, so this we have to add to 145.
Yes, yes, yes. That's what. So total area of cardboard required for box 1 will be how much? This 1450 plus 72.5. That will be 1450 plus 72.5. That gives you this point. Yeah. So it will be how much? Zero point 0.5, and this 0 plus 2 is 2. 5 plus 7 is 12. 5 1522.5 centimeter square will be the area required. Yeah. Okay. So what did we get? That is total surface area of a cardboard required for box 1 is this much. Okay. So we have to make 250 boxes like this. So the total area for 250 boxes, total area of cardboard required for 250 boxes will be equal to 250 into 1522.5. That gives you how much?
Sir,
Yeah,
sir, it is given that rate is 4 rupees per 1000 centimeters.
yeah, fine. We'll be doing that. First, we'll calculate what is the
Sir, so
total.
directly we have to multiply by 250 only.
We'll first find what will be the total area of cardboard required. Right? We have to make 250 boxes, no, of box 1 type. Right? So if you multiply this two, what you get is 380625. centimeter square. This is the total area of cardboard required for box 1. Okay. What they said, if the cost of a cardboard is rupees 4 for 1000 centimeters square, what is the rate? Rate of cardboard is rate of cardboard is 4 rupees per 1000 centimeter square. Yeah, that is 4 upon 1000 rupees per centimeter square. So if you divide it, what you get? 0 0.0 1 2 0 0.004 rupees per centimeter square. This is what the rate, 0 0.004 rupees per centimeter square. Now, what will be the cost of cardboard required? Cost of cardboard for box 1 will be equal to rate into area, right? The always it is cost is always equals to area into its rate. So cost of cardboard with the rate is 0 0.004, and what is the area required? The area required is 38065. Yeah. So you can also multiply and then take 4 times 4 decimal backside. So it will be into 4 into 0 0.004 equals 1522.5. So this is the cost of cardboard for box 1 type. Similarly, you have to solve for box 2 and you have to add both of them. That will be the total cost required. Got it? How many of you have understood everything? Please raise your hands. Please raise your hands if you have understood each and everything. You can
Can you teach the last part one more time?
converting. I have not converted. Acha, this one. See, rate of cardboard was 4 rupees per 100, no? Right. It was 4 rupees per 100 centimeter square. You can also write 4 upon 1000 rupees per centimeter square. So if you solve it, you'll get
What's the
0.004.
last part? Last part. Cost of the one.
Yeah, cost of cardboard for box 1. The cost is always equals to area into rate, right? Cost of anything. If the rate is in terms of area, rupees per area, so it will be in terms of rate into area, right? So that is the rate is 0.04. See, if you see the units of this 0.04, what is the unit of 0.04? That is rupees per centimeter square. And what is the unit of this area? That is centimeter square. So if you cancel this down, what you get? Rupees. Got it? Yeah.
Yes, sir.
Okay. Similarly, you have to solve for box 2 also and you have to calculate it. Okay. The same way. I have solved it only for box 1. You do it for box 2 also. Okay. And that's all. And you please solve this question in your homework. Yeah. Now what they have given over here, Parveen wanted to make a temporary shelter of her car by making a box-like structure with a tarpaulin that covers all the four sides and the top of the car, with the front face as a flap which can be rolled up. What? With the front face as a flap which can be rolled up. Okay. Assuming that the stitching margins are very small and therefore negligible, how much tarpaulin would be required to make the shelter of the height and with the base? It's the same thing. Again, you have to find the total surface area minus the base area of the tarpaulin. Because if you are using the tarpaulin as a shed for your car, you won't be using tarpaulin at the base, right? I hope you are aware about that, right? You will be using only at the top and in the on the four edges, four faces, right? So you have to what you have to do again total surface area minus the base area. Clear? You'll be able to do it as homework.
Yes.
Yeah.
So can you repeat one more time?
What can we?
So can you repeat one more time?
Okay, the explanation.
Yeah.
Okay. See, suppose if this is your car, right? if this is your car, okay, and you want to shed it, right, with a box. So what you will do, you will make a box, right? You will make a box like this, and you will do the shedding, right, with a tarpaulin, like this. Okay, the tarpaulin will be used where? Only at the sides, four sides, and at the top. It will not be used at the base, right? So what you have to do, they have given 4 meter by 3 meter, that is the base area, and the height is 2.5. So find the total surface area, deduct the base area, and then whatever the area you get, that is what the total area of the tarpaulin required. As they said, you have to neglect the stitching area and all,
Yeah.
right? What they said, assume that the stitching margins are very small, so yeah, you can neglect them. Actually, there will be stitching area also, no, which will be required. An extra tarpaulin will be required because there will be an area will be used for the stitching and all, right? I hope you guys have done some art kind of thing, right? You have to you need some
Yes.
extra area, right? For
Yes.
joining if you use a gum and all, right? So same for stitching also, right? So an extra area will be required. So they are saying that you can avoid that. You can neglect. Got it? You will be able to solve this?
Yes.
Yes.
Okay, fine. Now the next. So over here we are done with the first exercise. The next is about the cylinder. Okay, this is what my cylinder is. Okay, it has radius. Okay, this will be the radius. Okay, this is what the radius of the circle. It will be circular, no, at the base. It's a three-dimensional which I have drawn. Okay, it's a circle at the base and even at the top. And if I draw this line, this will be what? The height of the cylinder. Got it? This will be the height of the cylinder. So what all things a cylinder has? The radius, the height. That's it. Okay. If I want to find what is the total surface area, suppose, um, wait, can you see this paper? Yeah,
Yes.
it's a rectangular shape. Yeah. But if I fold it like this, if I fold it like this, you can see it. It is like a cylinder.
Yes.
Yeah, but if I open it, it
Yes.
will become a rectangle. Yes or no? Okay. So similarly, if I cut this cylinder at any one of the edge, and if I open it, what it will become? It will become a rectangle. Yes or no? If I cut this cylinder and open it, it will become a rectangle. It will become a rectangle. Okay. What will be this length? This length will be the boundary length of this circle. Yes or no?
Yes.
Yeah. What is the circumference of a circle? What is the formula to find the circumference of a circle?
Pi r.
2 pi
2
r.
pi r. That means this length will be 2 pi r. Yes or no? And this is height, so this will be height. Yes or no? So what is the area of this rectangle? That will be the curved surface area of the cylinder.
Yes.
Yeah.
Yes.
So what we can say, the curved surface area of cylinder is how
2
much?
pi r.
2 pi r into h, which gives you 2 pi rh. Understood? Why the curved surface area of a cylinder is
Good.
said as 2 pi rh? Clear?
Yes.
After that, the next is the total surface area of cylinder. The total surface area means this curved surface area plus the top area as well as the bottom area. Yeah. So if I want to find what is the total surface area of cylinder, if I want to find what is total surface area of cylinder, it will be curved surface area plus area of two circles. Yes or no? It is area of two circles plus the curved surface area is 2 pi rh. And area of one circle is how much? What is the area of circle?
pi r square.
So that is
pi r square.
2 into pi r square you have to do. Yes or no? Yeah. So if you add them, you can take 2 pi r as common in both of them. And what is left? H plus r. So we say it as 2 pi r into r plus h. Understood? How to get the total surface area of a
Yes.
cylinder
Yes.
and how to get the curved
Yes.
surface area of cylinder. Did you knew this formula, how to derive it before, or you have understood it now?
Sir, in school this was done.
This was done? Okay. Okay. Very good. How many of you have understood right now? You can raise your hands. Or you was already knowing it. How many of you have understood right now? What is curved surface area and what is total surface area? Okay, that's clear. What, how to find the curved surface area and how to find the total surface area, right?
Yes.
The next is what you have. Yeah, the next is you have examples based on it. Fine. Let's start with. Fine. Otherwise, what we will do, we'll start this in the next class only. Okay. The cylinder area
Okay.
and all. Yeah. We'll start in the next class. Okay. Chalo then. Bye bye everyone. Have a good day.